lesson 11.6, we're going to talk about recursion and some special sequences, and also talk about iteration and finding three iterates for a given function. When we talk about special sequences, there's one sequence that's probably the most famous out of our special sequences, and that's called the Fibonacci sequence. If you notice here, the Fibonacci sequence, and this isn't in your notes, but I want you to watch and listen. Basically, to find this term, I add these two terms. If I was going to find this term, I add these two terms, 1 and 2. To find this term, I add the 2 in front of it. To find this term, I add the 2 in front of it. So you're always adding the previous two terms to find the next term, and that is the Fibonacci sequence. So if we get into some actual examples here, recursion and special sequences. Basically, the definition of recursion. Okay. Each term is formulated from one or more previous terms. Might be from the previous term. We might be doing something mathematically to it. We could be adding the two terms prior to it or previous to it. It just depends on the notation. And again, with understanding these, you have to understand the notation. I have a note here. To be able to use the recursive formula, you must be given the value of the first term or terms so that you can start the sequence. And then you're going to use the formula to generate the rest of the terms of the sequence. Alright, let's look at this first example here. Find the first 5 terms. So we're looking for A1, A2, A3, A4, and A5. And I want you to notice they give me A1. So one of those first 5 we already know. Okay, this is the recursive formula right here. Okay. What I want you to notice, and maybe write down in your notes, is that AN we usually call the current term when we're talking about recursive formulas. And then A sub n plus 1 is usually the next term after. I'm just going to put after current, meaning the current term. So if you look at this formula, this says to find my next term, I'm going to take 2, multiply it by the current form, and then add 7 to the current term. Alright, so what I suggest you do here is line it up the way I'm doing it, because this is a real basic one. They do get a little tougher as you work on the problems in your assignment. So we know that A1 is 5. That's the first term. That's one of the terms we need to find, but it's given to us. So now I'm going to find A2. Okay? Now I'm going to find A2. And actually, I think I'm going to do it this way. Let's actually write down the recursive formula here. A subscript n plus 1 is equal to 2 subscript 2an plus 7. So, if I'm going to find A2, so in other words, if this is A2, it's very important that you realize what n is, because some of these recursive formulas, instead of having n in the subscript, might have an n over on the right-hand side. So you always have to understand what n is. Okay? So in this case, to find A2, n is going to be 1, because if I actually took 1 plus 1 right here, that would give me the 2. So n is 1 in this next one. I'm finding A2, n is 1. So I'm going to take 2 times A subscript n, well, n is 1, plus 7. So this really means take 2 times my first term, which is right here. So I'm going to substitute in here. This would be 2 times 5, and add 7. Well, that's 10 plus 7, so that's 17. which means A2 is 17. Okay, now we're going to find the next term. So let's keep going here. I'm going to find A3. N increases by 1 each time. Well, if I had n plus 1, it would have to be 2 plus 1 here, which means that n is 2. So now I'm going to do 2 times A subscript n. Well, n is 2 in this case, so it's 2 times my second term plus 7. So if I actually do that, it's 2 times 17 plus 7. So 34 plus 7 would be 41. So there is A3. Now if I'm going to find A4, that means n is 3, because 3 plus 1 would give me the 4 down here. That means n is 3. I'm going to take 2 times A sub n, or A3, and add 7. So I'm really doing 2 times 41 and adding 7. So I'm taking my previous term, multiplying it by 2, and adding 7 in this particular problem. 82 plus 7 would be 89. There's A4. And then to find A5, now n is going to be 4, because 4 plus 1 would give me the 5. So it's 2 times A4 plus 7. Well, A4 is 89, so it's 2 times 89, add 7. 2 times 89, add 7, should be 185, and that is A5. So the first 5 terms, A1 is 5, A2 is 17, A3 was 41, A4 is 89, and A5 is 185. You can either write them like that, or if you want to do 5, 17, 41, 89, 185, write them with commas in between. Either way is acceptable. Alright, then we're going to talk about iteration. And the term iterate is a process, or to iterate, I mean, is a process of composing a function with itself repeatedly. Find the first 3 iterates, which are x1, 2, and 3. So the first iterate is x1, second one is x2, third one is x3, given a function. They will always give you a function, and they'll give you x0. So x0 is 5. Okay, all you do is take your function. To find x1, I'm going to take, let's write down the function here. Okay, if I'm going to find x1, I plug in x0. So I'm going to put x0 into the function, which is 5. So I'm going to put 5 in for x. So right here I'll do 3 times 5, subtract 1. So that's 15 minus 1, which is 14. That is x1. Okay, so x1 is 14. That's the first iterate. Okay, we don't actually list x0 as an iterate. The first one is when you plug in the value of x0. Now I plug into the function 3x minus 1. Now I plug the 14 in. Okay, to find x2. So now I do 3 times 14, subtract 1. So 3 times 14 is 42, subtract 1 would be 41. So there is my second iterate. Okay, now I take that output to find x3, so let's put 41 there. To find x3, I'm going to plug in 41. So again, it's 3x minus 1 is my function. So I'm going to do 3 times 41, subtract 1. 3 times 41, subtract 1 should give you 122. So that is my third iterate, or x3. So when they say find the first 3 iterates, don't list x0. So it's 14, 41, and 122. So x1, x2, and x3. So the output of 1 is getting plugged in to find the next one. And that's the process of iteration, or how you iterate a function.